Welcome to the app Expanding and Reducing Fractions. The topic of expanding and reducing fractions is fundamental to the subject of fractions. It is essential, for example, in adding fractions that don't have the same denominator. The technique of expanding or reducing fractions is straightforward, multiplying or dividing both the numerator and the denominator by the same number. This app seeks to ground this technique in an intuitive and visual understanding. This app is based on the rectangle representation of a fraction. As we see here, we have the fourth written and a fourth of the rectangle colored. We'll refer to this rectangle as a bar. With the buttons on the side, we can hide the numerator, the denominator, or both. This allows the creation of a variety of questions. Now, when we click on the rectangle, it divides into a number of segments, so we don't just have the dividing lines, but individualized segments that give a very concrete meaning to the numerator and the denominator. The total number of segments is the denominator. The number of colored segments is the numerator. We can change the numerator, for example, to 2 or 3, and the correct number of segments is colored immediately. We can click the bar again to straighten it out, and the segments merge. Let's click it again. If we change the denominator, the bar also merges. With the plus button, we can add up to 4 rectangles. With the minus button, of course, we remove them. These are all the tools for the visual mode. Now, we'll give some examples of questions that we can create using these tools, and in the end, we'll see the technical modes. So let's move on to the next page. Here we ask the students, what fraction does this top bar represent? The students will probably guess a half, and we can click the rectangle and expose the denominator and the numerator. And this indeed is a half. Now, we can ask the students what the second bar is. They might say that it seems like a half as well, but we can tell them that the second bar is actually divided into more than 2 parts, and it's interesting to see how they'll respond. After their answers, we click the bar. We can see each of the 2 original segments is now divided into 4 segments. So ask the students, what fraction corresponds to this representation? So we have in total 8 segments, so the denominator is 8. 4 of the segments are colored, so the numerator is 4. And we can emphasize that since each segment is replaced by 4 segments, and that's why both the numerator and the denominator are 4 times the original number. Now, we can ask the students what the third fraction could be. Its value, of course, is half, but the question is, how many segments could it be divided into, and then how many of them are colored? We can gather different answers from the students and hopefully get different names for a half, 5/10, or 6/12, and so on. Okay, let's now show the numerator. And this large number might surprise the students. Well, we can ask them what the denominator is. One way to answer is to say the numerator is 30 times the 1, so the denominator should be 30 times the 2, which is 60. Let's click the bar. And we have 60 segments. 30 of them are colored. Okay, let's move on to the next page. The previous example dealt with the most intuitive fraction, the half. Here, we'll work on a fifth. The question here is, what could the bottom fraction be? After the students give their suggestions, we can expose the denominator. And now the question is, what is the numerator? So if this denominator is 6 times this denominator, then the numerator should be 6 times the original numerator. Okay, let's expose it and click the bar and also the original bar. When we have 2 bars, where one is the expansion of the other, we get these extra gray lines. These help emphasize the expansion. Well, in this case, the expansion is times 6. Each original segment is replaced by 6 segments. Also, emphasize that this shows not only expansion. If multiplying the numerator and denominator by the same number does not change the value of the fraction, then moving back to the original fraction by dividing the numerator and denominator by the same number won't alter the value of the fraction either. So, if we have a fraction of 6/30, we can divide both the numerator and denominator by 6 and get 1/5, or a fifth. Let's move on to the next page. So in this example, we deal with fractions that are not unit fractions. The top bar is 2/7. We can click it. Again, we can ask what the bottom bar could be and gather as many answers as possible. Students might start thinking more systematically and understand that the numerator and denominator can be multiplied by 2, 3, 4, etc., any whole number. So let's expose the numerator and have the students explain how they can figure out the denominator. So, of course, the expansion is times 4. Okay, let's click the bar. So, if each segment turned into 4 segments, the denominator is 7 times 4, 28. Let's move on to the next page. So, this is an estimation problem. The student's task is to estimate what fraction this is. So, we'll bring in an additional bar for tests. And from here, of course, we see that this fraction is less than half. The students might try to say a third. Okay, let's check. Oh, no, it's more than a third. This means it can't be a unit fraction. It's between a third and a half. Well, the students could try 2/5, and we can see 2/5 is too small. So it's interesting to see what suggestions the students might bring. Okay, well, let's click the top bar, and we see it's 3/7. Let's move on to the last page. Here we will see what we called the technical modes. Let's move to the technical rectangles mode. We drag the expand to. This is what we get, times 2 for the numerator and denominator. And we place it on the fraction and just let go. And we have the technique numerator and denominator multiplied by 2, and we get 6/8. And we also see this in the visual representation. The original divisions are bold, and the expansion added thin lines. We can erase this expansion by dragging a reset and placing it on the fraction. Okay, let's move to the technical circles mode. And we can do the same thing. So the circle mode is possible if we have up to 2 fractions. With the rectangle mode, we can have up to 4. Sometimes we would only want 1 fraction. So let's go back to visual mode, remove 1 bar, move back to technical rectangle mode, and we can check different expansions, times 2, 3, and so on. Okay, that's it. We hope this app helps the students grasp the topic of expansion and reduction and paves an intuitive way to the understanding of the algorithm. We hope you enjoy the app in class. Thank you so much for watching.